Good morning students. Today we are going to study the design of digital filters. So first of all, let me explain you what is the meaning of filters. Filter is a signal processing circuit. You can make different signal processing circuits which are called filters. What are the function of this filter is that it will attenuate some frequencies and pass some other frequencies. Now in very simple terms, let us take one example from our everyday life. Like we make a tea and when we are making tea, then after that we are using a strainer to remove the tea leaves from the liquid part of the tea. Okay, so what are we doing? We are removing those tea leaves. So the tea leaves are the unwanted part when you want to drink that tea. So that is the removal of the unwanted portion. So here also we are removing the unwanted frequency from the signal. So how we are going to remove those, that is the designing of the filter is related to that portion. Now let us go through this. Okay. So filter is a device or a process that removes some unwanted components or features from a signal. So after this you have two different filters can be divided into two different categories. They are called the digital and the analog filters. When you talk about this analog filters, give me a second. When you talk about the analog filters, then you have all the analog devices like resistors, capacitors, inductors, the passive components of the analog devices, that is the resistors, capacitors, inductors, all those, and the active components includes those op-amps and op-amps. So here you can make the filter with the help of these capacitors, inductors, or you can take the help of active components like op-amp, and with the op-amp you can take some capacitors and resistors. So that will design a filter for you. Other method by which you can design a filter is the digital filter. Those are called the digital filters. How do we design it? There are adders, multipliers, that is the digital devices, right? Adders, multipliers and tapped delay lines. With the help of this you are designing these digital filters. Now this is the general equation. If you write for the general equation for a digital filter, you will see it is somewhat like this: dk z to the power minus k, and this k will be going from 0 to say n minus 1. Yes, again. So this is so here it will be from k equals to 0 to say let it go till n minus 1. So these are the coefficient of this digital filter. So when you are changing the value of these coefficients, the digital filter will change. But in case of analog filters, what will happen that you will have to completely redesign it again. So that is the advantage of the digital filter. It is programmable. You just need to change the coefficients. So changing the coefficients are easy because you are writing a program for it. You can change the program, but for this you will have to design the full circuit once again. Okay. Now let's once understand why do we actually need these filters. Okay. So let's go to the next slide and see why do we need filters. Suppose there are basically two different reasons why we need the filters. One is the signal separation and the other one is signal restoration. Now let's see, suppose there is a person at point A. Let us say you are there at point A and your friend is there at point B. You want to convey an audio message, or you want to say something to your friend who is situated at B. So the signal has to pass from this point A to this point B. Right. So in the middle, what is going to happen is some noise or some unwanted signals can interfere with it. When they will interfere with your actual message or actual thing that you want to say to your friend. So suppose you want to say him hello. So if you want to say him hello and some extra things come in, and that makes it different from hello. Say I put a I over here, or say M over here, N over here. So maybe this type of this. So these are unwanted parts. So this happened because some extra noise came interfered with your actual signal. So and also what happens that even if the message is not even if this your message is completely the one you wanted to say, sometimes what is going to happen, the amplitude of this message, or you can say the value. Suppose this amplitude, say suppose it is 5 volt. Okay. Now when it got transmitted from A, when it was getting transmitted from A to B, the amplitude is getting decreased. So it is becoming say 2 volt or 3 volt. So this person at the point B is not able to hear it. Or the second type of thing which what can happen over here is that suppose here at this point you were sending it, and this was say at an angle at this point, the starting angle over here was say 45 degree. But when it, and here also when it was this portion, it was suppose some angle 45 degree. But when it is reaching over here, then it is becoming here at say 60 degree. So the phase change is happening. So there are two types of distortion that can happen when a message is being transferred from one point to the other. That is the amplitude distortion and the phase distortion. So you need to restore this signal. That's why we put repeaters are placed for long distance communications to reconstruct the distorted signal. That's why we place repeaters at every certain interval, so that that signal which has diminished or the signal which has been distorted, it can be transferred at the full, you say the original signal can be transmitted. So this is one of the reason we use the filters. The second thing is, part is signal separation. So what happens, suppose, what is signal separation? Then here I have given one example, that if suppose there is a so signal separation means separating the actual message from the noise. That is the meaning of signal separation. So suppose you there is a baby whose heartbeat the doctor wants to know. Now the baby is inside the mother. So what is going to happen is that the heartbeat of the mother is also going to come with the signals of the heartbeat signals of the baby. In order to remove the mother's heartbeat signal from the baby's heartbeat signal, we want some type of filter so that we can understand that yes, this signal I don't want to examine this the mother's heartbeat signal. I have to just imagine the baby's heart signal. So what I am going to do is I am going to use a filter to remove those signals. So this was about the need of the filters. I hope everybody has understood it. So these are the two reasons why we use filters, and there are the filters can be divided into two type of categories, that is the analog and the digital filters. So analog filters are used for continuous time signals, and digital filters you have the discrete time sequences. Now everybody knows the meaning of this analog and digital. Analog continuous time signal we denote it by x of t. So the analog filters are continuous are used to separate the continuous time signal, and the digital filters for the discrete time sequences. Here the major important thing is the full circuits need to be redesigned if any change is required. That's why it is less flexible. And this one, in this case, it is programmable. The full circuit need not be designed. So this is less accurate, or you can say there are tolerances that have to be made because the resistors, capacitors all are affected by the environmental, or you can say the operating conditions. That is, a temperature can affect the resistance. This is a thing, and this is less sensitive to environmental changes, noise, and disturbances. So this is more robust, the digital filters. Okay, now after this requires high performance ADCs, DACs, and in the case of analog filters, you do not require all those things because it is completely made from that way. Now, the main thing that you can understand, that the difference between the analog and the digital filters is that if emphasis is on the handling the performance of electronic components. So the components that you are using for designing the analog filter, resistors, capacitors, you have to pay attention that those components are accurate when you are designing an analog filter. And when you are designing a digital filter, your focus shifts. You just want your task to be met. So here you don't have to think about what is happening to the component. So this is another advantage of your digital filter. After this, what we have here is that every linear filter has three types of responses: impulse response, step response, and frequency response. What is meant by impulse response?